everyone. So, welcome to I think, the fifth episode of me modeling the robotic hand. Um, so, during the time between the episodes, I already printed out the hand and I was testing it out, or not really testing the bearings got delayed, so I wasn't able to have that. So I just thought like, oh, I'll just print it out, right, just to see how it's looking and how it works. And like I said before, the this the what is it called? The the computer distorts the actual scale of your parts. So when you look at it for so long, looking at it, it just looks so small, right? You're like, wow, okay. I mean, no, it doesn't look small. It looks huge. It looks big. You're like, wow, this looks big. And then I go ahead, print it out. Bam, printed it out. Look at the size of this compared to my actual proximal phalanx, which I just realized now that it's never phalange. It's actually phalanx. I don't know how I forgot about that, but you know, it's phalanx. Look at this compared to my actual proximal phalanx, in which in the movement, this whole part is the proximal phalanx of the hand. Which when I compared it to V2, I realized that they were exactly the same size, which that's okay. The thickness of this hand is kind of an issue, as to I want it to be more slim, right? So I'll definitely look into how I can kind of smooth it out and make it more of a human shape without compromising print quality. With blocks are very easy to print, but those complex shapes, it kind of puts stress on my printer. But as for the actual parts, they printed out pretty good. With no bearings, I'm still not able to test if it's actually going to be able to like work. But a couple problems I ran into was when you have the middle phalanx, the MP, when the MP is between the PP, proximal phalanx, when it bends, this little like kind of shovel looking bit, it actually bites into the Teflon tube, which I'm running through. So I'm gonna have to really fix that. Which it shouldn't be too hard of a fix. It's very simple. As for the tube, it in fact is pretty good. The string does run through it's very smoothly. And actually, the inside of this, which this part, it's just too like this. So I'm not gonna change it. No, I will change it, because when you do resin, it's not gonna be as forgiving, Well, for now, what I just do is I just heat up the tube and just put it through, and that actually seems to solve it in terms of it working, because it actually just clamps it into place. Since in the simulation it looks very large, but when I printed it out, I had realized that this whole part is very small. So since Teflon tubing is a very kind of rigid, hard material, it's very hard to bend it at angles like this when it's at such a small scale. So it's better to just make like a long piece like this and just put it through, which I'm just literally melting it through, but I think that's fine. But just these coming together, this works pretty well. As for this, you can see that this part is split in half for the screwing part, which that's not good because it's not gonna have adequate, um, I guess, tension between the walls of this and the screw when it's like that. So I'm gonna have to change that. I'm gonna have to put like a little chip right here for that to work. As for actually, as for the middle phalange is pretty good. There's not really much problems with it, except for it also has the same problem with this biting into the tubing when it comes out here. So I'll have to fix that, but so far it's looking really good. The bearings got delayed, like I said, so I probably won't be able to actually make a good like a simulation, I guess, for that. So, but that's okay. Not a good prototype. That's what I mean. But yeah. As for printing, these parts printed fine. This part is such like a weird part. It's not printing well. And as for this, um, the way that it's structured, the whole pulling or the gripping force of the whole hand, or just this, it's just this very weak section right here. I don't like the section at all. The way I designed it was not great, because look at this. What is the kind of the, what do you say, the central point in which all of the stress from grabbing something is focused on? Well, a chain is only as strong as its weakest link, right? And look at this. You're putting all of your grip, or just the entire structure of the actuator on, what is this, 1.25 millimeters of plastic, or of any sort of material, which that's just very small. And even if it's that, look at this. What's the distance between this and this? This is 2 millimeters. 2 millimeters. That is absolutely tiny. It's not great. So I think what I'll do is I'll have to strengthen this. Since this is already just such a big circular joint, there's no reason why I can't make this the same diameter of that, and I'll just push the rod through. I don't think there's any chance of it slipping out, so the rod will be good. So at least it'll have more structure behind it. I'll have to connect these two. These are still not connected, so that's kind of a detriment as of right now. So I think it'll be great if I just perfect the design. This is why it's always good to print it out and test it, because everything looks good on paper, and or everything looks good on simulation, but real life it's very different. And a problem that I faced was kind of shrinking of the prints when it's at such a small scale. The, I guess, not really shrinking, but the plastic expands, where it kind of off puts the measurements, and since a lot of these parts are very small and very need a good tolerance, it's not very great, just because of the fact that the tolerance is so small. The though even if you print it at a certain angle, or you print it in a certain way, it's not great, because the if you're printing up and the PLA droops down, that's a problem you gotta fix, right? And these smaller areas, like such as this, when I try sliding this into the groove, it literally wouldn't go in, because while the groove that it's supposed to go in shrunk, the actual material of this expanded. So it's just such a huge difference there. which it's minuscule, but it's still a difference. So it's not going in. And I also really like to round out these shapes. I don't think well, a robot doesn't really need. A robot can have anything really, but just what I'm looking for is kind of just a general structure with this curving, having a little bit of curves here, and this, just so it looks a little less blocky. And I bet that would help with ergonomics as well. But the actual MP joint is looking pretty good. It's pretty strong. It's a double ball. It's a double bearing, which I might actually change the width of this. So as compared to this one, in which it was a single bearing, I feel that a double bearing would be way better. And just because of the fact that it's stronger, and I'll make that sticker too, so it's not as weak. That's good. I want some of these parts to be like machined or kind of made out of a stronger material, just because of the fact that if you want to actually put this into I guess actually use this, it will have to be stronger. Yeah, there's quite a few flaws in my design, which I've yet to fix. So let's actually get to that. So first off, I'll just start by combining these two. I'm gonna make this same as that. Is it just one? I'm not sure. Yes, it is. Okay. I'll make that the same. I'll make this the same. These little grooves are showing up on the print, and it's kind of messing me up, just because. And I'm not sure why this is such a I'm not sure how to say it. I'm not sure how to explain it. I'm not sure why this is such a. I don't know why there's a line there, to be honest. It creates a line there. I've really never seen that happen before, so I don't know what's up with that, but I think this is fine. This is okay. I'll have to put a chip there. See if I can find my caliper. The actual Teflon is 4 millimeters in diameter, so I'll just put it so that it's I don't know, around, what is this, 10 by 3. Nope, make it 6. -1? No. Should be like -6. Nah. Yes. I'm gonna move this so I'm able to actually pull it down. Alright. What I'm gonna do is I'm gonna chamfer this all the way. So 1. It's not all the way, but it's fine. It's very minuscule. I'm gonna chamfer that. When it prints, it'll be fine. These, I'm a little afraid that they will break off. So I'll this is actually quite smooth in the way that it will probably. Why is this one piece? I thought I fixed that issue last time. When did that happen? I want to extrude this, right? Yeah. I'm gonna delete that. Okay. So this extrusion was poorly planned. And I'm gonna move that move. And as to the sketch. Six by 10. Move this down 6. Chamfer 1. Move it back. Hold on. Check. Yes. Move it back. Now we're gonna do test. It hits it right there. Well, that's pretty good. Now let's do another one. Right here. Alright. It's not bad. It's not bad at all, actually. It's very good. The movement is actually great. As for when it's like that, it would probably be when it's we can actually check how this will look. Maybe here. Yeah, let's check that. Is that in? No, it's not. Alright. So it's like here. Right. And then we get it at this joint. I don't know why that got selected, but this will probably be like that. Okay. You know what? Let's get this one in as well. So I don't want that, but I do want these and this. Let's get this one all the way. Before we do that, we also want to cut down a piece of this. So let's get this. Let's mesh that. Let's get I don't know, like, let's get like what is it? What was it? It's 10 by 6. Move this. Move these bearings. I just realized how small these bearings are. In the I guess in Dexan we didn't look that small, but you know, when I printed it out, I was like, wow, these bearings have to be like small, huh? Alright, let's move this back, and then we'll try doing a bend motion. So. Let's do, bam. Alright, right there. And then we'll do a bend motion right here. Which I don't know why I selected the ball bearings, but, you know. Which looks good. assign that, and I bet the tendon is able to go in all the way. So, and then we'll do a I don't know. we'll do a bend motion here as well, because I don't know, we can. This one, let's go. Oh, just that variant. This one, alright. And then this is gonna be all the way. It's not bad. It's actually really good in terms of motion. And look at the way it bends. Kind of bends weirdly like this, but the way that it will, it's not gonna do like a weird clawing as with most tendon-driven hands. Since the bottom is a solid state actuator, it'll just it'll go like instead of the top going like this and it's like doing that and it's doing that, it'll be more like smoother. One of the reasons why I had two actuators, not two actually, two servos, a two tendon system on the V2 was because of the fact that it would often when you would have I guess what's single tendon, right? What I really could have done was I could have just had a 360 servo just going down, and that would have made the V2 I guess slimmer and smaller, but it would have limited the capabilities just because of the fact that it's a clawing motion. That's not how you grab things. when you grab things, maybe that's good for like a couple. When you generally when you want to grab something, you want to go like in this, right? I mean, not like this. You want to go like that. So I bet this will be very good. From the side view, it looks very off. Like, what is going on here? I have no idea. You know what? Why don't I just get rid of this chamfer that I did? I honestly think I prefer fillet over chamfer. Because, yes, okay, it was that one. I don't know what was going on here. It's weird. Sketch 70. Alright. Let's do fillet. Let's fillet this. Wow. That actually did a lot more. With fillet, it's like it just be doing that. Why is it making that shape? I don't know. It just does. I'll actually keep a lot of things rigid for now. When you print, these like small weird gaps actually kind of mess up your print. It actually makes it take longer to print. I mean, 0.5 millimeter. It's not very relevant. Not even a millimeter. I mean, jeez. Let's fix this, which we will do by this this component is kind of not good. I'll be honest. Since these are just so small, it doesn't make sense as to why I would honestly even have it like that. It would be better if these were like larger. So I'm just gonna take this out and mirror it, so I'll just edit one of these. This one. So let's get this. We honestly don't need this. And then, what is the diameter of this? This is like, I don't know, 9. Looks good. Looks good. I'm actually gonna move this down just so I don't get confused on what I'm looking at. Since the overlaps kind of annoying. This is very small, anyways. So I actually don't think I want to be having it in such a I guess that is very small. So what I'll do is I'll just make it like that, where it's just two more, yeah. So I'll move this up. What did I just do this? So I think it's fine if I just screw these guys in right here. So I'll just put one hole through so that you can actually just screw it through. I think that'll be better. So you can just screw it in on this side, screw it in on the other side. As for an actual I fear that the width of this is a little too much. So I'm gonna move this too. Okay. It's clearly not the right idea. I'll move this too. Well, what is the length of this? 5 millimeters. I don't think the screw will be kind of long enough for that. So I'll go here. I'm gonna do 2 extrude. On the other side, I'm gonna do 2 extrude as well. I'm gonna extrude this inwards too. Well, what's the height of this? It's 5. So it's a perfect 5 by 5. Other side. Okay. I think this is okay. I'm really gonna need a lot of M2s for this, so look how nice this part looks. It's just one, but this would be a nightmare to print. Nightmare. Actually, I bet it wouldn't be too bad. If you print it just like this, on this, no, but like this, on like as in this, print from here as the bottom, I think it wouldn't be too bad. Especially with something like tree sports. So I'm gonna delete that. And with that, it actually looks pretty decent. So just like I said, I'll probably actually just combine these two into one, to be honest. I don't see any harm in that. The less parts, the better. Okay. For this, what I'll do is I'm gonna raise these up so that they're not just so fragile that they will break. I'm gonna raise them up by 2 millimeters. Now I know that looks crazy giant, but it really isn't. In terms of real life, it's very, very different. I mean, even something like 3 looks very small. Real life, this will look very different. As for this, I'm just gonna fillet it around 2. Two fillet. I don't enjoy how fat that looks actually. Real life, this looks very small. It's almost flat. The end is almost flat. But okay. The CAD model has a what do you say? It's a tendency to distort things, and that makes everything look huge. And it really isn't. I quite dislike how awkward this piece is, in the way that it is kind of, I guess, in the way that it's in its design. I kind of don't like it. It looks very weird. There's just this big step right here, but it's okay for now. One of the problems that I was talking at the beginning, right, was that what was that one problem that I was talking about in the beginning? In that it pinches the Teflon. I already fixed that, so I think it would be better if I kept each phalanx as a single piece instead of like V2 with it having be multiple pieces. That kind of messed me up. Oh, that's what it was. This was the as for the tolerance on these, right? I I don't really like how this is just so close to it. I feel that in real life, if something were to happen and then the it doesn't become when it prints and it just kind of warps or something, this won't be able to be as as fine as I would want it to be. So I'm actually gonna send this back a little bit. And I don't know, somewhere around here. Alright. So I'll send this back. What was it? -2, I think. No, it was actually -3. Yeah. That's good. That worked out for the most part, except for the fact that it chipped away this. So I'm gonna go back to this. I'm gonna change it from 15 to 13, which that's better. That's a bigger, more give for the wheel, or the bearing, I should say. All right, I'll do it on this other side, or no, I'll actually just mirror it, because I don't want to be doing that again. There you go. Did it work? No, it did not. So I'll actually split it first, and then I'll mirror it. Mirror on that side. Bam. So we actually have a duplicate right there, which this duplicate can be removed. I want to remove it so it doesn't destroy any of my old constraints that I had, which somehow. Okay, now it's good. Alright, now let's make sure this part is nicely made. Even though this looks like it would be a nightmare to print, it's actually not that bad. When I printed it out, it wasn't doing anything crazy, so it's actually quite good. I'll just expand that. I'm not really enjoying how this is the difference between that is a 7. So I'm actually gonna move this down. That looks pretty good. I'm gonna move this until it's level with that, so it doesn't have that weird part. Or I'll actually expand it or extrude it until it's joined with that, just so it doesn't have these weird looking parts. I don't quite enjoy how those look. What is the space between this? A weird number. So what is this? That's 1, perfect. Okay. That makes it weird. I don't like that. It's this small gap just kind of rubs me the wrong way. So that's okay. For now, I'll just extrude this into this, and I think this is okay. I'm not confident as to how big this is. This is 2.3. It's actually quite small. In IRL, it's quite small. So that's pretty good. Looks good. I'm gonna move this back. This pin, I don't think it would pinch here, but I know this would definitely touch that. So we gotta resolve that issue. So let's find the middle point here. I don't need that, but all the way I would want it to go. And yeah, it's not good. I feel that for that side, we can kind of just, I'll actually do this. This is 2. So what I'll do is I'm gonna make an extrusion of negative 2.5, right? Negative 2.5 here, which these should be connected, so that it doesn't form a weird looking thing. So I'm gonna do negative 2.5 like that, and I'm gonna raise this 2.5, or I'm gonna raise it until it's level. So what's the level of this? 2. I'm gonna move this, raise this 2, move it back, and then I'm gonna look for so it's a 2.5. I would actually prefer if these were if the line between this and this was connected. So and it looks like there's a very small gap or some sort of overlapping thing. That looks very weird. So I'm gonna move this. I'm not sure what the space between this and this is. This is 3, okay. So I would actually want it to be 3. Going from here, 3. And this is 2.2. Good. I'm gonna raise this by 2. Make sure this is good. Look at the intersection, okay. What's the overlap on this from here to here? 0.5. Alright. Negative 0.5. Move it back. That's good. I'm gonna do a split here. Go back. So I'm gonna do a construct. Negative 2.5. With that negative 2.5, Or actually not even negative 2.5, just negative 3. Negative 3. I'm gonna split this body right here. Bam. Okay. So with this, should be good if we just do this, right? Nah. I'll actually bend this into place and find out precisely where it would be. So it seems like it'd be kind of in that bend, huh? Because no, it actually wouldn't. You could go a little bit more. Maybe like this much is good. So actually, we can probably just fillet that, or just chamfer it for more. I guess for more. Rigid, or kind of for more like blockier polygonial look. So let's chamfer this. Chamfer it. 13. Let's see how that looks. That actually. So it seems like it would really only be going up until that section where it bites that right there. So I chamfer here of 1.5. Assume one chamfer of 1 right there. When we try moving this, I just want to make sure it aligns with that. I see, so it kind of hits that right there. So these small chamfers don't really be doing nothing. It doesn't make sense why you would have these small bits when they probably wouldn't even show up in the print. So let's this part kind of looks off. Such a skeletal design. Okay. Let's just try it again. How much would I want the MP joint to bend? How much does your MP joint bend? Around this much. That's not bad. How much is it intersecting here? How do I do a planar cut so I can see through? I actually don't know. Look at orbit. Nope. How about we look at the wireframe? So this edge is actually on such a. We're having this intersect and that intersect. So that's not great. That's not great at all. what I would need is a I don't know. I would just want. I don't want to chamfer this because this is not even with that, and it wouldn't look good. I could chamfer this, which it's also not really. I'm not sure that'd be a good idea, but I could try to round down for 2. Chamfer. Let's try this. Oh, hold on. It's not bad. It's actually not bad at all. And then what if we do a 2 chamfer right there? And then let's try. Okay. Actually, it's pretty good. That's about how much I want my MP joint to bend. Let's try how much. Let's try maximum bend with the DP as well. What the heck? I want it to bend right here. Right here. Is that? Nope, it's not. Okay. And these don't need to be connected. Let's go. Okay, so this one's like that. This one was like that. As for the end, it actually works out pretty well. Just in the way that it bends, you wouldn't want it to be bending too much, right? I'd say that's pretty accurate to a human hand bend, like that. That looks pretty good, and I actually quite like how it's more rounded now, so it's like more human. Which there really is. It's kind of a weird dilemma with humanoid hands. Like, why do hands need to look humanoid when you just have claws, right? And with that, I would say that like, you know, you would want your, since that's just same as saying, like, why would robots need to be humanoid? Well, because a lot of people say the world is built around humans, and you want these robots to be able to interact with the world, and I guess that is really kind of the main driving point. But you know, ever since the dawn of time, ever since the dawn of man, it's always been kind of dreams of many people to create an artificial life form for which it resembles a human. That's kind of something that a lot of people have been working towards achieving, and it's reached staggering amounts of progress in recent years, especially with lots of new firms coming up. It's like a Cambrian explosion, really. Like we've had I guess humanoid robots, like so DARPA projects, whatever, but they've never really been kind of mainstream. I mean, they've just been like a project where people they created it. They were like, well, this is not really going nowhere. It's just too impractical, too expensive to be able to scale it, right? But now you have this new wave of humanoids, in which much development is being made, Even in 2020, we haven't really seen much of these new humanoids, like such as what was it, Atlas. We've seen Atlas before, but never really some things like Unitree. I don't even think Unitree was established back then, was it? No, it's been established since 2019, so it has. So it hadn't made the H1 humanoid yet, I don't think. But yeah, especially I think the currently the most impressive that I've seen is definitely the G1 in terms of capabilities. Now the H2 is awesome, but G1 I've seen do way more things than H2. The H2 just released, and the only demo that or like the prototype that I've seen in it wasn't functional, so it wasn't like very much of a spectacle. But the things I've seen G1s do is insane. I mean, yeah, I bet its smaller size and stature helps with it being able to do a lot of moves, but yeah, it's still crazy. I mean, even 5 years ago, people see that they'd be like, "Oh, that's CGI, it's fake," but it really isn't. They can do flips IRL too. Um, yeah, I mean, I think that the growth of this new technology is exponential. At first, it was like it's going up, and it hit a roadblock where it was like AI. Like, oh, we already, well, I bet I don't think the hardware back then was very good, but the biggest challenge is just how to control it, you know. And it was like it's going up, and it's like, oh, we got like this diesel engine, a roll humanoid. It's hydraulic. It's hydroelectric, and it's pretty good. And it's like, well, what does it do? And if you got the hardware but you don't have the software, what can you do with it, right? But especially in the exponential growth of AI in recent years, I think it's been um, able to grow just crazy. It's going like this, and it's like, oh, it's hit a roadblock there, and then but now it's just every every few days, really, or just every day. I see new stuff about humanoids coming out. Oh, this new humanoid came out. This lab scaling. This new demo. The new feature. New AI. Um, new models. I mean, it's it's quite impressive just how far it's come in such a short time span in the basically the last 3 4 years, really, and especially the last 2 years. It's the growth just shot up. So yeah, that was my tangent about humanoids. But let's go back to work. mm, what was I making here? Oh yeah. Okay, so this meets kind of nicely there. uh um, i don't I don't know if this chamfer is necessary, if it does quite, if it really does meet so nicely there. If only I could like X-ray or like cut through this. How do I do that? How do I cut through to see the middle? Yeah, melee. Let's do this. Uh, did I actually press A? Yeah. I'm gonna hide this. I'm gonna hide this one, and then I'm gonna split. No, I forgot to combine this actually, and this should be combined as well, because it is one part. Combine this and this. All right. I'm gonna split this, and this in half. I'm gonna take this, this, and this, and this away, so I can see the middle. And now I can really see what's the real story here. Goes, oof, I see. So it's like, now we do the chamfer method, where we chamfer this by 2. Now let's see what's going on. Still doesn't cut it. Now, what we can do is we can just, instead of chamfering this, one as well, we will just kind of make something up as to how it will be, which honestly, the way it's being stopped right now is not too horrible. I actually don't think this is bad at all. Like here's, it's not bad. Your middle phalanx is it doesn't need to bend that much, to be honest. It should really only be going at it kind of a maybe from a perspective like I don't know. Definitely maybe like just this much. This much is fine. So I'll actually just cut back on this to make more room. Oh crap. Yeah, I'm gonna get rid of that split. And then I'm gonna get rid of this. And then why don't I just cut back on this? I don't know, like -2. That's kind of a lot. -1, which that's not bad. That's not bad at all, actually. I don't know. It's quite mind messing. It's messing with my mind as to what kind of motion I would want it to be. So I'll just actually use the one I printed in real life, and I'm gonna use it to clip it off. So I don't know, simulate the joint, or like the thing that I made where it's like it's good. So take off this joint, and then let's just see how it would work. So it's like this, and then around this much, and then with this one would bend around this much. That's actually quite good in terms of just how much. I mean, this would be able to grasp most objects. Now, while it is quite good, I would actually want it to be more so. I don't like how that looks at all. It just looks very bad. I'll be honest. It looks very cheap, or not cheap. It just it doesn't look great. But I think it's okay for this purpose. As for the bend here, this honestly works on its own. I think this is fine. There shouldn't really be any problem with this. So I think I'll just leave it as it is. Unless I want it to be like that, but it's not what I want. I'll leave it as it is for now, and we'll see if there's any real problems when we assemble a prototype. As for this one, your actual your proximal phalanx doesn't really bend that much, so this is actually quite good for this. Maybe, yeah, no, this is good. This shouldn't have any problems. Maybe this should be kinda. I wonder why it's not orbiting on the points. It's orbiting around the center. I want to orbit around these points that I make. But it's orbiting around this. It's so weird. Okay. So we did quite good on some progress here. As for that joint, I don't really know what I'm gonna do with it, to be honest. There's not much of a problem here, to be honest. I don't think this is bad at all. This is actually quite good, to be honest. I mean, it bends. Bends pretty good. Shouldn't be an issue. As to yeah, that's fine. It's cool. Now, what's not fine is actually, I think this is good for now. Everything will be revealed when we make the prototype and see if the tension strings are working correctly. But yeah, it's quite good. I don't see any problems with it. So this MP is quite a complex piece. To be honest, it's quite complex. Okay, I think that's good. That was actually honestly really great progress. So once the bearings arrive, that's the moment of truth. Once the bearings arrive, we see, and we'll just know if we fucked up some things or if we actually did God's work. So yeah. Once I finish the V3, I'll actually make a control glove for it. It shouldn't be too crazy difficult, since it's a single servo. It's like a single actuator system. So except for the thumb I'm gonna have to do some sort of gimbal thing, but that's okay. For the thumb, I'm actually thinking of using a solenoid for the open and closing, and then with the solenoid you can have that, and then maybe you can have like a ball joint or something. So when you move it, you can have a actuator here, and then just a tendon thumb. Maybe I'll have a solid thumb. Thumb is honestly one of the hardest parts of a humanoid. Not a humanoid robot, just a humanoid hand. Just because of the movement and the muscles surrounding it's very complex. But yeah, okay. Well, thank you for watching. I'll see you in the next session, video, stream.